All right, welcome back. Today we're doing flood fill. Let's check out flood fill. It's our first graph problem, I believe. It's week 1. An image is represented by an M to N integer grid image where image ij represents the pixel value of the image. You're also given 3 integers, SR, SC, and color. You should perform a flood fill on the image starting from the pixel image SR, SC. Okay, so you can imagine you're using Microsoft Paint. You got that little paint bucket, and that is the XY coordinate or the row column coordinate of where you're clicking. To perform a flood fill, consider the starting pixel plus any pixels connected 4 directionally to the starting pixel of the same color as the starting pixel, okay? Plus any pixels connected 4 directionally to those pixels, also with the same color, and so on. Replace the color of all the aforementioned pixels with color. Return the modified image after performing the flood fill. Okay, so you have to modify the image and mutate it. Well, let's start drawing. Let's shrink this a little bit and think about how to solve this problem. So I think immediately what you have to think about is how to traverse this graph. So they're calling it a graph, but visually you probably see a square, right? But the way you think about it is like every one of these nodes has essentially an up property, a right property, a left property, and a down property. Now they're not called that, but that's what these squares are, seemingly connected to, and that's how you'll navigate, right? So this, how do you draw a bucket? It's like if this is the bucket, is this how you do it? So this is your flood fill bucket, and it's here, and this is the, the R and the C. Then the up, if it's if you have a class here and it's a node, it would maybe be node, it would be that whatever, however you do it in your language, right? Self dot up, self dot right, self dot down, self dot left. Here, because we're using row and columns, then up is not, there's no dot up. Up is going up a row, right? So this would be like row minus 1 at C. Doesn't really fit in there. Row minus 1 and C is the up. Right is row, but it's column plus 1. Down is row plus 1 at the column, and left is the same row but column minus 1, right? And that's how you would navigate this graph. Okay, so let's take this and let's imagine what's going on. There's a 1, 1, 1, 1, 1, 0, 1, 0, 1, and this is our example, right? And I believe they're flood filling this one. So let's go ahead and take this and flood fill it, right? And what it's going to do is it's going to fill everything else. So this one is going to fill this one. What's the, okay, let's look at the example. This SR is 1, the SC is 1, and the color is 2. Okay, so, right, you'd imagine you'd flood fill this one, so this 1 becomes a 2. And you'd look here and you'd, consider that this is the, okay, so the original color is whatever was flood filled first, right? It's like SR, SR, SC. That's the original color, right? So as long as it's the original color, you check against it, and you find that that is the original color, 1. So that also becomes 2. You're not only going up, you're going in every direction, right? You're going in every direction, and this also becomes a 2. This 0, or this 0 does not become a 2, and this is what happens after one iteration of going in every direction. Okay, perfect. So what happens now? Well, we can call this recursively on any place that we visit, right? So maybe a visit. So let's say there's a function called visit, and yeah, let's say there's a function called visit, and it takes I guess a new R and a new C, right? And if the current value is the original value, then we want to make a change, right? Change it. Otherwise, I guess if it's not the original value, we can just stop. If it is the original value, we change it, but we also want to call this recursively, right? We recur, by calling visit on, I guess, every direction. So you recur, up, and the four things, right? Up, right, down, left, right? So in every direction. Just gonna make it easier on myself. Up, left, up, right, down, left. Okay. And if it's not, what happens when you get to the 0? Do you recur on every position after the 0? Probably not, right? I mean, definitely not. So else you just return. You just don't do anything. And so let's just imagine we recur up. So we recur on this 2. I'm going to change the color, make this green here. We recur on the 2. So let me delete this before. So before it happened, this is a 1. And we called recur on up. And we change that to a 2. And then we do this also in all 4 directions. Now, do we go back down? We could keep a visited array so we can avoid going back down. That's something we can do. Or we can just kind of let it ride, because no matter what happens, if we already visited this, it won't be the original color, right? So I guess that's a trap. If we were changing from one color to another color, then we don't need a visited array. But what if the original, let's say, was 1, right? And then the color that we're supposed to change it to is also 1. Do we get stuck in a trap? We might, right? Because then now we totally get stuck in a trap. So actually we have to check against that too. So if the value is the original, we do that. But maybe we even just, as a quick check, if the target is original, we just return out of this. We don't do, quick exit, let's say. Yeah, totally a quick exit. Okay, so that gets us out of there. So now at this point of the code, we know that we're always looking for a new color. So we're changing from 1 to 2, right? Go ahead and delete this. So we're changing from 1 to 2. Now, what happens here, right? Bad, very bad. Now we've gone out of bounds. So we have to check for bounds as well. So, maybe we'll do it at this point where we have an early exit. If out of bounds, we also return, right? So if out of bounds, we return. If the value is the original value that we're flood filling, we, change the color, and then we do that recursive thing, or else we return. Right, and at the end of this, we return the original painting, or whatever this is, right? Your MS Paint thing. Okay. That is about everything we need, or at least to start coding, to start looking at it. I guess another thing that we have to think about as well is that this has told us that it wants us to return a modified image. So when we return image here, you know, we're going to want to consider that this is mutating stuff, right? So if we have any go function, we're probably going to want to, in Python, non-local image, and this is going to allow us to change stuff, right? So just something to think about. So the go is going to take a row position and a column position. So I'm just going to call this row, call this column, and the original, I guess, I don't know why they're using s source row, I guess, or doesn't matter. The original row and column. And you know, so let's think about what we wanted to use as state. We wanted to use this original one because as we're flood filling, we want to know what we're changing it to. Oh, and we also want this early return, right? So if the image at this row and column, right? So if this color is equal to the color, that target color, we want to just stop. We don't want to do any of this flood fill. So just return image, right? So at this point, we know that we're changing the color. We're going from 1 to 2, 2 to 1, 0 to 2. Doesn't matter. We know that we're legitimately changing a color. Okay. So let's check if we're out of bounds. Let's do that later. So check out of bounds. And then check if value is the original. And then else return. Okay. So that means we got to save the original, right? So the original, I'll make this larger for people to see. So the original is where? It's actually here. So I guess I could have saved this. Maybe it makes it more clear. Where if the original is the same as the target color, then I can consider this already flood filled. Okay, so check out of bounds. Check if this is, check if the value is the original. Okay, so what do I call this? Color at position, something like that. You know, the image is this row and column, and if the color at position equals the original color, then I want to go ahead and, you know, do all this stuff. I want to change the color for one. So the image at this row and column is going to be equal to this target color. And then I want to call this recursive function on, up, you know, in all these directions. And that's going to be r minus 1 going up, r c plus 1 going right, r plus 1 at c going down, and r c minus 1 going left. All right, I'm just going to go ahead and fill those. And I guess I don't really need this return, because if it doesn't happen, then, you know, this implicitly, the return value is not used anywhere. So this is, I guess in C, this would be a void function. So if it's not here, then the else is nothing happens. It's just doesn't continue mutations. So let's check out of bounds. Now I have to check out of bounds before I do this, or it's going to throw an error. So what is out of bounds? So if the row is smaller than 0, or if the column is smaller than 0, then this is invalid, right? So I just return here. So that's on the 0 side. What is the upper bound? So that's the lower bound. What's the upper bound for the row? The lower bound is always that 0. So the upper bound of the row is the number of rows that exist, right? So for an image, that's going to be the length of the image. And then the number of columns for an image, it's going to be the length of, I guess, anything in that image, any row in that image. That's going to be the number of columns. So this could throw an error if there's 0 rows. So I guess we can, you know, if the length of the image is 0, then we just want to return the image, right? So now we know that there's some length to the image. So here, I'm going to take the first row, and that's the number of columns. So if the row is larger than or equal to the number of rows, because this is index 0, it shouldn't be that way. Or if the column is greater than or equal to the number of columns, also index 0, shouldn't be that way, then I just want to return out of this go function, stop any mutation that's possible, or else I'm getting that color at that position. And if it is that original color, I want to continue this fill. And I only want to continue the fill until it's the original color, right? When I get to the 0, I don't want to continue the fill. Okay, this is a good start. Maybe there's some iteration we have to do, but oh, okay. Yep. See, if this is a Google Doc, I maybe would have never seen that, and that would have been bad. So, you know, if you're going to say R and C for short, you should keep it consistent. So it's accepted it on these. These cases are typically pretty small and not the edge cases. So let's see if this works for the edge cases as well. All right. This is the code. And that's FloodFill. Thanks a lot.